Now, since we've been talking about inverse functions, we might as well go ahead and do target 5.7 now, because this is your inverse trig functions. So we know our trig functions are sine, cosine, tangent, cosecant, secant, and cotangent. So we know those are our trig functions. So now we're going to talk about the inverse trig functions, the ones that are undo each other, that are the opposite operations. All right, so we are going to learn how to differentiate and integrate the inverse trig functions. These are basically formulas. You don't have to know all of them. There's typically only 3 that the AP exam even has on there. And typically this might be 1 or 2 problems on the whole test. So this is not a heavy concept. So most people don't really memorize these theorems, but they just, or memorize the formulas. They basically look for patterns so that they can just pick the right answer in a multiple choice question or something like that. All right, this is not a heavily tested area. All right, so inverse trig functions, let's start with what are they? So we know these problems over here. So we know that the sine of pi over 6 is 1/2, okay? So the inverse would be who on the unit circle has a sine value of 1/2, and the answer would be pi over 6. So you would be starting with the value that you get off the unit circle. So you would be starting with the 1/2, and you have to get the pi over 6 back, okay? So that's if we would, the problem will sometimes look like this. The sine of theta equals 1/2. So you know the sine is 1/2, so you're looking for what angle on the unit circle gives you a y-coordinate of 1/2. Okay, so these are the 3 forms of it. So arc sine and inverse sine. Inverse sine is not as popular. It's usually arc sine or the sine with a -1. So you'll see arc cosine, inverse cosine, cosine with a little -1, or you'll see arc tan, inverse tan, and then tangent with a little -1. All right, so these all mean the same thing. Slightly, the little differences maybe in the domain of the function, but they all mean that who on the unit circle, what angle on the unit circle gives you a sine value of 1/2, which is a y-coordinate of 1/2 on the unit circle. So when you're thinking on the unit circle, who gives you a y-coordinate of 1/2, that means you go over a lot and up a little. That would be right here at pi over 6. Okay, there is another answer over on this side, but these have restricted domain. Woo! And the domains come from the first quadrant and the fourth quadrant. So we have restricted domains where we're dealing with the first quadrant and the fourth quadrant, not the second and third quadrant. So we don't want this answer over here that's over to the left a lot and up 1/2. So we don't want 5 pi over 6. We just want the pi over 6 first, and then the fourth quadrant is a negative answer, so we don't want that one. All right, so inverse trig functions are functions where you're given the answer for the value on the unit circle, and you've got to figure out what radian measure on the unit circle has that value, either for the sine, the cosine, the tangent, whatever we're doing. All right, so working backwards, okay? So that's your inverse trig. So now we're going to do the derivatives and the integrate these things. So let's talk about differentiation first. So they've gotten it written as an arc sine. So again, you might see inverse sine, or you might see sine -1 in place of those. So these are the 6 derivatives. So the derivative of arc sine of some function u, this can be any function f of x, is the derivative of that function divided by the square root of 1 minus the function squared. Okay, the arc tan is the derivative of this function divided by 1 plus that function squared. There's no radical, you notice, in that one. And then for the arc secant of u, it is the derivative of u and then divided by the absolute value of u and then multiplied by the square root of u squared minus 1. So whatever this function is behind here, the numerator always has the derivative of that function. And then in the bottom, there's some type of calculation with that function in it. Okay? All right, so now, over here, if you look at your arc cosine, your arc cotangent, and your arc cosecant, those three are exactly the same as these guys over here. The only difference is they each have a negative sign. All right, everything else is the same. So arc cosine, the derivative of arc cosine, is exactly the same as the derivative of the sine, but it has a negative. All right, the derivative of arc cotangent is exactly the same as the derivative of arc tan, but it has a negative sign. And then same with arc secant, is the same as the derivative of arc cosecant, except the arc cosecant has a negative sign. So once you know these three, then you got these three. You just have to know who matches with who. Okay, and it's always the same. Sine and cosine, tangent, cotangent, secant, cosecant. Okay? So now, the things I notice is what helps me remember and memorize these is the tangent one, the arc tangent, has no radical in it. To me, that's always the easiest one. Recognize him first. All right, in the same way with the arc cotangent. The difference between the arc sine and the arc secant, you will notice here, this one says 1 minus u squared, where down here in the arc secant, it's got u squared minus 1. And it's real hard to remember which one has the 1 first and which one has the u first. So here's how I remember it. In the arc secant, he has the extra absolute value of u, and so his starts with the u's next to each other. So you've got this absolute value of u, the square root of u squared minus 1. So that's how I remember it. The one that has the extra, which is the secant, has this extra expression for the absolute value of u in here. So it starts with the u squared. Okay, that's how I remember it. Now, integration. The good thing about integration is on the AP exam, they only care about 3. These are the 3 that they care about as far as integrating. Okay? So when we integrate, you're going to have 1 divided by the square root of a number. A is some value, some number. A number squared minus a function squared. All right? So that's going to be the arc sine of whatever this function u is divided by this a value. And all this is a formula. It's not hard at all. Notice the arc tan is the one that doesn't have the radical in it again. It's 1 over a number squared plus a u squared. So the answer is going to be 1 over a, arc tangent of u divided by a plus c. And then again, the arc secant one is the one with the extra u, the extra function on the outside of the radical. It also starts with the u squared first. They're beside each other, minus some number squared. And that answer is 1 over a, arc secant of the absolute value of that u divided by a plus c. Now, you'll notice too that the only one that doesn't have the 1 over a, the coefficient, is the sine. So that's another thing you have to remember when you're working through these. All right? So basically these are formulas and rules that you just need to match them up. They're not meant to be complicated. They never give ones that are real hard to do. You usually can eyeball it or figure out which one it is, as long as you kind of have a familiarity with these theorems, okay, with these formulas.